Okay, so now we're going to work on the second part, the second set of this final exam review. So this is set 2, and we're going to go through questions 11 through 20. So let's get started with number 11. And number 11 reads, let the supply and demand for bananas in cents per pound be given by the equations below. So we're going to write down the equations. So that the supply equation, P equals 3 over 5Q, and the demand equation, 100 minus 2 over 5Q. Supply always has a positive slope because it's a line that is rising. As price goes up, it's common sense, you know, as the price per product increases, more suppliers are willing to increase supply. And as the price of the item or the product increases, there's less demand for it. That's a normal good. So that is why demand has a negative slope, because as the price of that product increases, people are less likely to buy it. Now we're going to graph the equations. So the instructions are, we graph the equations on the same axis. We find the equilibrium quantity, we find the equilibrium price, and then we want to see what happens at a price of 41 cents per pound if there is a shortage or a surplus of supply. So let's see. So we're gonna switch the order a little bit because it's easier if we find equilibrium quantity and equilibrium price first. Once we have that point, that is where the two lines are gonna intersect, then we can graph the curves, or actually these are not curves, these are lines. We can graph the demand line and the supply line by finding two additional points, and then we can see what happens in terms of whether we have a shortage or surplus. So let's get started. So we're gonna first begin with part B. They should have ordered that differently. First find equilibrium quantity and equilibrium price, and then we'll take it from there. So let me stop sharing here. And so let me make sure that you can see that. And I know it's a little bit blurry, but it's going to get a little better now as I start writing. I think it's better now. Okay, so where does equilibrium happen? Where demand, so remember equilibrium happens when demand equals supply. So that is where this happens, right? So we're going to let the demand equation, 100 minus 2 over 5Q, be equal to the supply, 3 over 5Q, and we're going to solve for Q. So we're going to, because Q has to be positive, it's quantity, what we're going to do is we're going to add 2 over 5Q to both sides, or 2/5 Q. We're going to add it to both sides. And that's going to cancel negative 2 over 5Q on the left side. And so bring down 100. And then we have 3/5 Q plus 2/5 Q on the right side. And so we have 100 equals 3 over 5 plus 2 over 5, because we have the same denominators we can add. So we've got 5 over 5Q. And so the 5's cancel because 5 divided by 5 is 1. So 100 is equal to the equilibrium quantity. And in order to find equilibrium price, you take the 100, right? And you can plug it into either the supply equation or the demand equation. And the supply equation is easier. So now we let Q be equal to 100. And then we have P equals 3 over 5 times Q, which is 100. And so we see that that's going to give us equilibrium price. So 100 divided by 5 is 20 times 3 equals 60. So we've got the equilibrium quantity and equilibrium price. solve. So we have, this is where the two lines are going to intersect. Now, as you remember, so this is actually part B, but we started with part B because it makes more sense to do so. Okay, so now that you have equilibrium price and equilibrium quantity, you can create a graph here, right? And remember that what we can do is maybe go in tens, right? Or I can go all the way to 150 here on the Q. So you see you have a 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and so on. And then similarly here, right, we can go like that in tens. And for the price, so we've got price on the left, and then quantity. You already know where equilibrium happens. So it happens at 100. Remember, equilibrium price is equal to 60, and equilibrium quantity is equal to 100. So at 160, there is so right here, they're going to cross, right? The two lines are going to cross at this point. So this is, so Q is 100, right? And P is 60. So you've got the point right there where they cross. Now, to graph the supply and the demand, we're going to need at least another point. Now we can look at the equations again for demand. Let's write them here in supply. So demand is 100 minus 2 over 5Q, and supply is 3 over 5Q. So if we can look at the intercepts here, so if we let Q be 0, right, for the demand, look at the demand. If Q is equal to 0, then price is 100. So you have another point here. So if Q is 0, the demand will be 100. So we can have another point right there. So 0, 100 for demand, right? So if Q is 0, you can let the Q be equal to 0 here. So you get P of 100. Now for supply, if Q is 0, then it's, 0, 0 here. Okay. And, it will be a good idea to get another additional, at least one more point for each line. So let's do demand right here. I'm going to do it on the side. Let's do demand and find another point. So the equation again is 100 minus 2 over 5Q. So if I let, for example, say, it could be any Q, say 50, but just be smart about the Q that you pick because it has to be divisible by 5. So if Q is 50, then price, you just plug it in. You erase it up so you can see it there. So if I pick 50 for Q, plug it into your equation and you get 100 minus 2 over 5 times 50. And so the price would be, you can see that the price will be 100 minus 50 divided by 5 is 10, so minus 20, that's going to give us 80, right? So you get 80. So that gives us another point there for demand, and that is Q is 50 and price is 80, okay, for demand. And similarly, you can do the same thing for supply. So you pick, say, for supply, again, you let the supply equation, which is 3 over 5Q, and let Q be equals to 50. So P will be 3 over 5 times 50. So price will be 50 divided by 5 is 10, so it'll be 30. And so you get another point here for 50 for Q, and then price is 30. So you get your 2 points there. That's going to help us graph the lines, okay? So we have the 2 points. Now let's go ahead and graph. So remember, we found the equilibrium price and quantity, which is quantity is 100, price is 60. I'm going to put a dollar sign over here at 60 so you know that's price. And now we have additional 2 more points here for demand. So let's do the demand first. And at 50 for demand, 50 for Q, right? 50 for Q. So you've got 50 and then 80. So you get a point 50 and 80. You get this point right here for demand. And remember, demand is going to go down. So it goes through the equilibrium and then it does that, right, for demand. And then for supply, you have a Q of 50 also, and it's 30. So you've got that at 50, 30. So you get, it goes through like that. And so that would be your supply. So you can see how you can go like that for supply. And that gives you a graph that of the demand line and the supply line where they cross at equilibrium. Okay. We have the demand line that is falling because remember that as the price of an item drops, the demand increases. So it makes sense that it's a falling line. The supply line is increasing because as the price increases of a particular product or item, there's more likelihood that the suppliers are going to want to produce that. So that's why supply is a line that is rising as the price increases. Now, what happens at 41? So the next question is what happens at 41 cents of supply. So you got to look at the supply equation now to answer this question. This is your supply curve. So what happens at 41 cents? So you got to find here 41 cents. And you have to see what happens at 41 cents. What is the supply at 41 cents? Well, let's take a look. So at 41 cents, we go to supply. Supply is about 80, close to 80 cents. Sorry, it's 40 cents. It was 41 cents. So at 41 cents, supply is about 80. So they're willing to supply. So the suppliers are willing to produce 80 units of this product at 41 cents. Okay, so suppliers, you can write suppliers are willing to produce about 80 units at 41 cents per unit. But now look at the demand. So at 41 cents, so now you go to the demand. So at 41 cents, how many the consumers want to buy about 100 and I think it's about 120. I'm a little off on the graph, but it's like like around 120 units. So then consumers, so you see this is how you explain, so suppliers are willing to produce about 80 units at 41 cents. Now consumers, when you look at the 41 cent price, go to the demand line and you see that they're willing to buy at least 120 units. So consumers are willing to buy about 120 units of the product at 41 cents. So what happens if you have consumers willing to buy 120 units of this product, but suppliers are only willing to supply about 80 units, you're going to have a shortage of about 40 units. So there's a shortage. You're going to say there is a shortage at 41 cents. There is a shortage. Okay, so that is how you go about answering this question. So we went through all the parts. So remember, the first step is finding the equilibrium price and quantity. And there I'm showing, let me go ahead and show everything here because sometimes the screen is not big enough for everything I write. So there's the first part, finding the equilibrium price and quantity. We found that in the first part of the question. And then, we find additional points so we can get an idea of the graphs. And then we look at 41 cents, the price of the item, and we see that there's going to be a shortage because more buyers are willing to buy at that price than what consumers are willing to produce. So we have a shortage. Okay. All right. So that's question 11. So moving on to the next one. Let's go to the question here. And we have question 12. What does that say? It says that the revenue for a restaurant chain in billions of dollars for the year 2010 to 2015, so for over 5 years, can be approximated by that quadratic function. X equals 10 is the year 2010. Okay, so now we have the revenue function given, and we're going to find a vertex. So let me write down everything so I can share my screen here. I'm going to try to fit everything, hopefully. It's hard sometimes because there's so much here, but let me see. Okay, maybe if I move my camera a little bit there. All right, so the revenue equation is given by -1 over 2x squared plus 13x minus 45. Okay, we're going to find the vertex A, find vertex. And then we're going to find in what year during this period was the revenue at a maximum. So find year of max revenue. And then what was the maximum revenue? So find max revenue. All right. So here's the equation. Let me focus this better. All right. And now let me try to straighten it because I think it's a little bit. So if I move this like that, you can see better, right? Okay. Now, how do you find the vertex? Well, this is a quadratic function in standard form, so I cannot read it from the function itself because it's not in vertex form, but there's something we can use to find it, which is called the vertex formula. Right, and so the vertex formula, we need to identify A and B here. A is the coefficient next to the x squared, so it's going to be -1/2, and then B is the coefficient or the number next to x, so that's 13. So then the vertex, remember that the vertex we write it in the form hk. So in order to find h, you take minus b over 2a, and so minus b would be minus -1/2 divided by 2 times a. So then a minus and a minus, when you multiply them, you get a positive. So you have 1/2 divided by 39, right? Sorry, 26. And now what we have here is and over here, so minus b, and you know what? I made a mistake here in this question. I apologize. Let me try it again. It's minus b over 2a. So ignore this, please. So ignore this. It's minus b. I switched them for some reason. That was my mistake. So minus b, so it's minus 13. I apologize. Minus 13 divided by 2 times a, so 2 times -1/2. And so we get -13 times 2 times -1/2. So that's going to be -1, right? When you go ahead and multiply that. And now we have a negative divided by a negative is a positive, so I guess that gives us 13. So the year, because remember h represents x. So you can say that x equals 13, right? So that represents the year. And remember that in the problem, they told us that x equals 10 was implicit of 2010. So this is going to be 2013 as far as the year, right? So that's going to be 2013. So now, but we're not there yet. So this is the 13 is the h in the vertex. So you can write 13. Now we have to find k. In order to find k, you plug in the 13 into the quadratic equation, right? And so to find the k, you take 13 and you plug it into the quadratic equation, the formula that we have here. So it's going to be -1/2 times 13 squared plus 13 times -1/2, right? So negative 1/2 times 13 squared plus 13 times 13. 13 times 13, yes. 13 times 13 minus 45. And then we get, so again, so you're plugging in the 13 because that is the x, right? So negative 1/2 times 13 squared plus 13 times 13 minus 45. When you use your calculator, right, we get, okay, so negative, and then we're going to plug in 1/2, and then we're going to multiply that times 13, and then we're going to square that, and then plus 13 times 13 minus 45. And so we get 39.5. Okay, so 39.5 is the K value. So the vertex is 13 comma 39.5. That is the answer to the vertex. And sorry about this mistake here. Please don't get confused by that. It is, so I start right here. The formula is minus b over 2a. So be careful here. When you do minus b over 2a, the mistake I made is that I switched these. For some reason, I saw them backwards. I apologize. So it's minus b. So let me just go back and minus 13 because it's minus b. So b equals 13. So minus b and 2 times a. So 2 times negative 1/2. We get a negative, and then 2 times negative 1/2 will be negative 1. So we get a negative divided by a negative is a positive. That gives us 13 as k. 13 is my age, and now to get the k, you take the 13. So 13 is the age in the vertex, which is really the x. And then you take 13 and you plug it into the quadratic equation, the formula, and then you get the k, which gave, we got 39.5 for k. So the vertex is 13 comma 39.5. Okay, that's part A. Now part B, we can answer part B because it says in what year, find the year of the maximum revenue. That happened, that's the x because x represents a year. So you take x equals 13. That means that the year is the year 2013, using the definition provided in the problem, right? Because they told us that x equals 10 is the same as the year 2010. So x equals 13 is the year 2013. Now, how do you find the maximum revenue? You have to take the maximum revenue. It's when you plug in, we have the answer already because you take the year 2013 and you plug it into the revenue function. So we did that. It's the same thing as taking the year 13. Don't put 2013, just put 13. And so you get, so negative 1/2 times 13 squared plus 13 times 13 minus 45. So we did that already in part K. In the when we were finding K, we did it. That was part when we found the first part of the problem when we were finding the K. So we got 39.5, but I think we're asked to round. Let me look here. They told us to round to the nearest. Yes. So we have to round to the nearest billion. So because it's 39.5, we're gonna round up to 40 billion. Okay. So I'm getting it from the 39.5. So the maximum revenue rounded up, right, is going to be 40 billion because it's 39.5 billion, right? When we solve this, remember we did it when we were finding K. So now it's going to be 40 billion when we round up to the nearest billion. Okay. So that's the answer to question 12. All right. This one had a lot of parts. So question 12 is done. We answer parts A, B, and C. Now, moving on to 13, let's see. So in a certain region, the fatal accident rate per 100,000 licensed drivers can be approximated by the function f of x equals 0.0382 x squared minus, you can see the function. X is the age of the driver, and this is range, the domain is from 16 to 88. So that's the age that we're looking at. Age is from 16 years old to 88 years old. Now, it's asking at what age is the rate at the lowest? Okay, this is, so we're looking for if we look at the function, that's a quadratic function, so it follows the shape of a parabola opening up. So that means that the vertex represents the lowest point because the parabola is opening up, right? So we're looking for the x because the lowest h happens at the vertex. So you don't have to do the algebra here. You just read what value represents the lowest, and you know the rate. In order to answer A, B, C, or D there, it's going to be the value of the vertex, so it's D, right? So the x value of the vertex. So here we know this from the definition of the vertex, right? And so the answer here is D. Now, to find the lowest, the rate is the lowest at age. Well, we actually have to, in order to answer this question, the rate is the lowest at age. We have to find the x value of the vertex, right? So we have to look for it using that formula. So let's go ahead and let me write down the, okay, so got 13 here, number 13. Let me write down the function. So it's f of x equals 0.0382 x squared minus 3.09x plus 113. And so we're looking for the age because we have, remember, this is a parabola. If we were to graph this, it's going to be a parabola opening up. So the vertex is the minimum point. So we have to find this vertex. And h is the x, so that is the age. So x represents the age. So we want to find h because that gives us the age where this is at the lowest. So we have to find that. So we need A is 0.0382, and then we need B, which is negative 3.09, right? And so remember, h is equal to minus B over 2A. So minus B is minus 3.09 divided by 2A. So it's going to be 2 times 0.0382. So that's a negative times a negative is a positive, 3.09 divided by, and we got to get this. So 2 times 0.0382, that gives us 0.0764. When you divide these two, we get, so 3.09 divided by 0.0764, it gives me 40.44502618. So we're going to round because it's 40 point, so the age is about 40 years, right? So the rate, we can say the rate is the lowest at age 40. Okay, you can answer that like that, at age 40. And I think that's all they're asking there. Let's take a look here. The rate is the lowest at age 40. Round to the nearest whole number. Yeah, so because it's 40.44, we'll just round to 40. Okay, so that's 13. Now, moving on to 14. And I'm moving a little bit faster because there's so many questions we got to get through. So we've got 50 questions, but this set is only 10 questions. Okay, so question 14. It's a similar question as the one we did about supply and demand, 14. So here we have suppose that the supply for a certain textbook is given by the supply equation and the demand is given by that demand equation where P is the price and Q is the quantity. The graph of these equations is shown to the right. Find equilibrium quantity and equilibrium price. So this one, we don't have to graph them because, you know, it's already given there. So we already did a graphing question. Now let's go ahead and find supply and demand. And remember where that happens, where the supply and demand intersect, that's when they're equal, right? So the demand P is equal to negative 1 over 5Q squared plus 30. And the supply equation is 1 over 5Q squared. Okay. Now, we have to set demand equals supply for equilibrium. So equilibrium happens. So equilibrium happens where demand equals supply. So we can have the demand equation. So negative 1 over 5q squared plus 30 equals supply. 1 over 5q squared. So we want to keep the q's positive. So what I'm going to do is I'm going to go ahead and add 1 over 5q squared to both sides. Okay, that's going to get rid of the negative 1 over 5q squared on the left side, bring down 30. And so we've got 1 over 5q squared plus 1 over 5q squared. You can add these two, right? And that gives us 30 equals 1 over 5 plus 1 over 5 is 2 over 5q squared, right? Equals 30. Now what we can do is get rid of this 5 by multiplying both sides of the equation by 5, which gives us 150 equals, the 5's cancel, and we get 2q squared, right? Now when we divide, we take 150 equals, I'm going to write it over here. So divide by 2, and we get 75 equals q squared because the 2's cancel. Now, I'm going to write the equation a little differently. I'm going to write q squared equals 75, and I'm going to apply the square root property, take the square root of both sides, and remember you get plus or minus, but because it's quantity, we don't include the negative really. So it's just q is equal to the square root of 75, right? Now the square root of 75 is if when you solve for that, there's gonna be it's gonna be 8.66. So Q is 8.660254038. So we're gonna just round to the nearest whole number. So we're gonna say, you know, Q is 9, right? We can say that, rounding to the nearest whole number. So the equilibrium quantity is 9. Now you take this equilibrium quantity and plug it into the supply curve because that's the easiest one to get the price. So now plug, so the supply is P equals 1 over 5Q squared, right? So go ahead and plug in the Q equals 9 there to get the price. The equilibrium price is going to be 1 over 5 times 9 squared, right? Now, if you do this, you'll get an approximate P, but you know, it's probably better for the to get a more precise equilibrium price. Go ahead and use the non-rounded figure, the non-rounded number for Q, the one previous to rounding. So I'm gonna use that because I think it'll be better, more accurate. 8.660254038 squared. So if you use that, then equilibrium price will give you 15. If you use the when you use your calculator. Because if you use a rounded Q, it's not gonna give you this the equilibrium price of 15 is gonna give you something a little bit off. So just use. So we only round, so you're probably wondering, so how do I know when to round? You round the final answer only, not the middle. Anything that is a middle step, you don't round. So let me show you everything here. Make sure you get everything, and then I'm going to move up the paper here a little bit so you can see. Okay, and then to the side so you get everything, and then down. So to find equilibrium price, make sure you use the non-rounded figure for Q star for equilibrium quantity, and you plug it into the equation, okay? And that's how you find equilibrium price and quantity. Remember, equilibrium happens where demand equals supply. So once again, when you set the two equations equal, you solve for Q, and you will need to round. Now, to answer Q, the equilibrium quantity, you're going to round the very last the final answer you round to the nearest whole number. To the nearest whole number you round, but only the final answer. Now, to find equilibrium price, you're gonna use the equilibrium quantity that is not rounded. So that will give you a more accurate equilibrium price, which is what I have here, a more accurate equilibrium price. Okay, that's 14. Okay, let's move on. So 15 now. Yeah, these questions are not, simple. I'm gonna organize the paper here. It's all over the place here. Yeah, these are not easy questions. They take work. All right, 15. We've got find the profit function for a corporation for the years 2004 to 2012, given the revenue function and the cost function. Okay, so this is just a definition question because remember, revenue and costs are already given. And what is profit? Well, think of your own finances. I mean, it's what you make minus what you spend. So profit is revenue minus cost. So all you have to do here is take the revenue function and subtract the cost function. Okay, so let's write it down. So this one is actually pretty straightforward. I'm glad because the other ones they've been requiring a lot of work. So, okay, revenue is negative 0.0611 x cubed plus 1.754 x squared minus 11.38 x plus 123.3 cost equals negative 0.0168 x cubed plus 0.908 x squared minus 7.27 x plus 96.6. Okay, now you take revenue minus cost, that gives you profit. Okay, so this one you have, okay, profit is equal to the revenue minus the cost. So what you're going to do is you take the revenue function, which is negative 0.0611 x cubed plus 1.754 x squared minus 11.38 x plus 123.3, and you're subtracting a cost. Now, because you're subtracting multiple terms, please go ahead and put them in parentheses, okay? And then you write negative 0.0168 x cubed plus 0.908 x squared minus 7.27 x plus 96.6. Now, what's going to happen is that this negative is going to change the sign of everything inside the parentheses, right? And so when you combine these, make sure you can see that and make sure you change the sign. So what you end up with is, you're going to end up with negative 0.0611 x cubed, right? This doesn't change, plus 1.75 x squared minus 11.38 x plus 123.3. And then you start changing the signs. This negative makes this one a positive, so it's going to be plus 0.0168 x cubed, and the negative changes this into a negative minus 0.908 x squared. This negative changes that one into a positive plus 7.27 x, and this negative will change this one into a negative minus 96.6. Now, once you're here, you just combine the like terms. So you're going to take this and you combine it with anything that has the same power and the same term, the same letter here. So you're going to combine these two, right? And that's all you can combine there. So the first term, and for the sake of saving time, I'm just going to write the answer here, but you just combine. It's just combining like terms now. And so then you get, for the first term, when you combine the negative 0.0611 with the positive 0.0168 x cubed, you get a negative 0.0443 x cubed, right? You can see that with the calculator. You can see that. Look, let me show you. Negative 0.0611, right? And then plus 0.0168, and you get a negative 0.443 x cubed. And you do the same with the square terms right here, right? That will give you, when you do that, you get a positive. I'm just going to write the answer here to save time. But now you know what to do. So 0.846x squared. And then after that, you do the x term. So this combined with that, which will give you the negative 4.11x. And then lastly, the constants. You combine these last two constants. You get a 26.7. This is your profit function right here. That's the profit function. Okay, profit function. Revenue minus cost. Okay, excellent. Now we move on to number 16. Okay, this one should not be too hard. It's just graphing a rational function. And when we're graphing a rational function, we start by finding the x and the y intercepts. So let's do that. We'll find the x and the y intercepts, and then we'll find the vertical asymptote, the horizontal asymptote, and then just kind of look at the behavior of the entails after that, and we get an idea of the graph. So let me write the function here. So we have a rational function, f of x equals 3x divided by x minus 2, and we want to graph it. So it says give the equations of any vertical asymptote and select the correct choice. So we have to find the vertical asymptote, and then we have to find the horizontal asymptote, and then graph it. So it also helps to find, when you're graphing a rational function, you want to find the x and the y intercepts. So let's start with find the x-intercept, and then you're going to find the y-intercept. And so to find the x-intercept, remember that for the x-intercept, the y is always 0, and for the y-intercept, the x is always 0. So you can start there. And so the y is 0, so you get 0 equals 3x divided by x minus 2. Solve for the x. So you can multiply both sides by x minus 2. And so that's going to cancel the x minus 2 in the denominator. And x minus 2 times 0, that's just 0. And then you get over equal to 3x. And then divide by 3. And so 0 divided by 3, that's just 0. The 3's cancel. And so x is equal to 0. So you see the x-intercept is 0, 0. And then to find the y-intercept, you let the x be 0. So you get, you can write y, right? Or f of x, y equals. And then you let the x be 0. So you get 3 times 0 divided by 0 minus 2. So then y will equal 3 times 0 is 0. 0 minus 2 is minus 2. So y is equal to 0. So the y-intercept is also the 0.00. So the origin is both the x-intercept and the y-intercept. Now, so that's the first step. Now, second step is you want to find the vertical asymptotes and the horizontal asymptotes. So again, I'm going to write the function here. So you've got f of x equals 3x over x minus 2. The vertical asymptote, we find it by setting the denominator equal to 0 and solving for the x. So x minus 2 equals 0, add 2 to both sides, and we get x equals 2. So then the vertical asymptote happens at x equals 2. Now the horizontal asymptote, we find by looking at the degree of the numerator and the degree of the denominator. And if the degree of the numerator is the same as the degree of the denominator, then you take the ratio of the coefficients. So the degree of the numerator is 1. The degree of the denominator is 1. So then the ratio of the coefficients, 3 over 1. So it's going to be 3 divided by 1, which is 3, right? So then y equals 3 is the horizontal asymptote. Okay, so remember how that is done. You look at the degree of the numerator, and if it's the same as the degree of the denominator, and what is the degree? The highest exponent. So here's 1 and 1, so they have the same degree, right? The degree is the largest exponent of the numerator, so x to the 1, and then x to the 1 over here too, so you have degree 1. Then you look at the coefficients, and you take the ratio of the two coefficients, 3 and 1. So 3 divided by 1 is 3. So the vertical asymptote is y equals 3. Now, you can start creating your graph now, right? And then you see that we have a vertical asymptote at x equals 2. So let's say this is x equals 2. So that's x equals 2. And then you have a horizontal asymptote at y equals 3. So y equals 3. And then the graph goes through the origin, because remember the x and the y intercepts. So then you know that you're going to have something like, now you're going to have, I want to use a color that we have. Okay, so the graph is going to go like that, and it's going to go through the x. It's going to go through the origin. Now, how do I know that this is going to follow, that the end tail here, as we approach the vertical asymptote from the left, the way to know if this end tail is going to drop is by, let's say you pick a point, say x equals 1, and look at and plug it into the equation. Say 3 times 1, that's 3. 1 minus 2, that's a negative 1. So 3 divided by negative 1 is negative 3. So you know that the y will be negative when x is 1. And so you can see that the end tail then is going to be falling here. Same thing you can do right here, as the graph, this is going to follow this trend also, the end tail is going to go up. And the way you can determine that is by picking an x, say, equals to 3. Plug it in here. 3 times 3, 9. 9 minus 2 is 7. You get a positive. So, that's how. So pick some x values as we approach x equals 2 from the right, and as we approach x equals 2 from the left, and then that's how you will know that the end tail coming from the left is going to go down here to negative infinity, and the end tail will go towards positive infinity coming from the right by selecting x values to the right of the vertical asymptote and to the left of the vertical asymptote. And that's how, so the graph will be something like that, like that. Okay? All right, so that is question number 16. So moving on to question 17. Let me move up the graph a little bit here so you can see. Let's move on to 16. Oh, that was 16. Let's move on to, so the answer is, remember, x equals 2 for the vertical asymptote, y equals 3 for the horizontal asymptote. And then for the right graph, this is going to be the one that looks like our graph. It's going to be the only one that looks like our graph is probably C, right? So the answer is C, right here. Okay, move on to 17. And it reads, the assets for a financial firm can be approximated by the function a of x equals 308 e raised to the 0.045x. X equals 7 corresponds to the year 2007. Okay. Find the assets for each of the following years. Okay, for this one, A, B, and C are the same in terms of the steps. So I'm going to do one. I'll show you how to do A, for example, and let you do the others for practice. And remember, you have the answers in the back of the review, so you can verify that. But so that this video is not too long, I will show you how to do A, but because B and C are exactly the same, except for the year, you can do that, right, for practice. And so let's go ahead and write the equation here for 17. So the equation that will give me the assets in billions of dollars is A of x equals 308 and then times E raised to 0.045x, and x equals 7 corresponds to the year 2007. Okay, find the assets for the year 2013. So if I want to find the assets for the year 2013, 13, what I'm going to do is I'm going to plug in 13 for the year 2013. And this is going to give me 308 e raised to the 0.045 times the year 2013. But remember, I just use x equals 13. So I'm going to use my calculator here. E is Euler's number. You don't have to worry about what is the value of Euler's number. The calculator will give you the value for that, for Euler's number. Okay, so 308. Look for Euler's number. Make sure that you're raising it to the power 0.045 times 13. And that gives me in a value of 552 0.857 something. So I think we have to round. Let me look at the rounding instructions. The rounding instructions, let's find the assets. Well, it doesn't say, but it's in billions of dollars. So usually we just round to the nearest billion, right? So you know what? I'm gonna round to one place after the decimal point. So 552.9 billion. Okay, for that year, for the year 2013. And you can do part A, B. So this is part A. So for part B, it's gonna be for the year 2014. So you plug in 14. And for C, you plug in the year 2017 is you plug in 17 for X, okay? But follow the same steps. So that's question 17. All right. Let's move on to 18. Here we go. There's question 18. Now, this one reads the amount of money. So this one has a little bit more work, right? And we're gonna do some it's similar to the previous one, but not part B. Okay, so 18, it reads, the amount of money in trillions of dollars that is invested in passively managed mutual funds can be approximated by the function. And so let me write down the function for 18. So the function is a of x equals 0.32 and then 1.18 to the x, where x equals 1 corresponds to year 2001. And we're talking about trillions of dollars. Okay, in trillions of dollars. Now the first question is, what was the amount of money in passively managed mutual funds in the year 2011 and in the year 2016? So I will do 2011, and you guys can do 2016 since it's the same process. So for 2011, what we're gonna do is we're gonna plug in. So remember, this is question 18. So for 2011, we're gonna plug in 11 into the function. So we have a of 11 for 2011. And so we have 0.32, 1.18 to the 11th power. And this is going to be in trillions of dollars. And so let's go ahead and plug that in. So 0.32 times 1.18, excuse me. And we raise it to the 11th power and we get 1.97 something. So let's go ahead and keep, I'm gonna keep two numbers after the decimal. It's in trillions. So 1.98 trillions dollars, 1.98. Okay. $1.98 trillion. Okay, so that is this is the first part A. And you can do part B in a similar way. Well, actually, part B, I believe it's still part A. Let me see. Let's take a look here. So part A is just plug it in, right? Now, What was the amount of money in the year 2011? So still part A, you guys do the 2016 year so that you can practice. Now, I'm going to move on to part B. Remember, you just plug in 16 to get the amount of money in invested or managed in mutual funds in the year 2016. Just plug in 16 into the function. Now, if the trend continues, what is the first full year when the amount of passively managed mutual funds exceeds 7.6 trillion? Okay, so how do we answer this question? We're looking for the first full year when the amount will exceed 7.6 trillion. Okay. Well, the way we answer this question is we set up an equation where we set up an equation like this. Let me show you. So I think we need a clean piece of paper because this one requires a little bit more work. So the equation we're going to set up is, so we have the equation that's, we have a of x is equal to, this is our function that's going to give us the estimate, right? And we want to find the first full year where this will exceed 7.6. So what we're going to do is we're going to let the a of x be equal to 7.6 and then write the equation as 7.6 equals 0.32 and then times 1.18x. And we're going to solve for the year. Now this is going to give me the year. Now notice, this will give me the year where it is exactly 7.6 trillion. So I'm going to have to move up a year in order to answer the question because we want the first full year when it will exceed 7.6. And what I'm solving for is exactly 7.6. So I have to move to the next year. Whatever year I find, I'm going to have to move up to the next year. But first I have to solve for x. Now, solving for x is not as simple here because this x is an exponent, is not a linear function. This is an exponential function. So we're going to have to use the exponential properties, right? First thing is I need to get rid of 0.32. So I'm going to divide by 0.32. And we get 7.6. And I divide that by 0.32. And we get 23.75 equals 0.32 cancels. And we get 1.18 to the x. Now, you can't divide by 1.18 to solve for x because x is an exponent, right? So I'm going to have to turn this into a logarithmic equation. So I'm going to take the ln of both sides. So ln of 23.75 equals, and then the ln of 1.18 to the x. This will allow me to use my logarithmic properties. So then applying, remember the log property that says that the log base a x to the r is equal to r times the log base a argument x. That's what I'm going to use here. So the power will come down here. So this is going to be x. So x comes down. This is equal to x, applying this property, this logarithmic property, x times the ln of 1.18 to the x. Well, the x is over here on the side, so we lose the x here, right? So we bring down the x, applying the property, so we get x times ln of 1.18, and then we get the ln of 23.75, okay? Now, what we can do is, to solve for x, I can divide both sides by the natural log of 1.18, both sides, natural log of 1.18, and see the natural log of 1.18 on the right side cancels. And so we get x is equal to the natural log of 23.75 divided by the natural log of 1.18. And we see what we get here. So let's take a look here. And we have natural log 23.75 divided by the natural log of 1.18. Close the parentheses there. And we get 19. So x is 19.13780187. So remember, this is the year 2019, but this gives me when when the amount of assets managed in mutual funds is exactly 7.6, and I'm looking for the year where it is the first full year where it exceeds 7.6, so I have to move up a year, so round to the next one. So x equals 20, so then the first year will be 2020, where the amount will exceed the first full year where it will exceed 7.6 is going to be 2020. Okay? So it's going to be 2020 for the answer there. All right, so that is question 18. So let's go ahead and move on to the next question, because the next question is not as simple. It has several parts. So let's do it. Let's go to question 19 now, right? I think it's the next one. So that was question 18. You just needed to find so we were able to find what we needed to find for 18. So for 18, we are done. Now we move on to, so remember, for 19, I'm over here now. Let's see what we are looking for here. So it says, a National Census Bureau predicts that a certain population will increase from 31.5 million in the year 2000 to 63.9 million in the year 2070. Complete parts A through C. So we have to find the exponential function. So this one's harder because we have to start from scratch pretty much. And we have to use this information and then we have to plug it into this form of a function, exponential function form. And then we're going to find the constant of growth, which will be the b here. Yeah, it's b. We have to find b, the constant of growth. And to do that, yeah, it's going to be a process. So A, B, and then once we find B, then we can answer those questions. Okay, so let's get started because this one has several steps. So first, let me write down what I know. So I know that population increased from 31. So we have to have some, let's collect the data. And so population, we have population and we have year. And the population, we start with 31.5 million. And 31.5 million, that happened in the year 2000. So that's going to be my starting year. So I can say that that's t equals 0. And then in the year 2007, the population went up to 63.9 million. And that happened in the year 2070. So t there is 70, right? Okay, now, how do we, and then the equation, let me write down the form. So we have f of t equals y0 and then b to the t. Okay, now, so this is what I have. Let me show you what I wrote down. I'll explain. So I have population, and this is my data. So in the year 2000, population was 31.5. In the year 2070, population went up to 63.9. And then, of course, that happened in 7 years. So now I'm going to use this equation here, and I'm going to plug in what I know. So using this equation, right, I start with 63. So let me write down the equation. So f of t equals y0 b to the t. So I'm going to start with 63.9. This is the future. This is when population increased. So that is always the future amount. 63.9 is equal to y0 is always the beginning. So that's going to be 31.5, right? And then I'm looking for b. I don't have b. But I know this took place from 31.5 went up to 63.9 in 70 years. So I can say that t is 70 here, right? But I don't have b. So first we have to solve for b. And again, it's similar to what we did in question 18. So we're gonna divide both sides by 31.5 here to get rid of the 31.5 because you're looking for B. And the 31.5 will cancel here, so we get B to the 70 power. And then this gives me, we gotta look for that. Let me see. So 63. So we get 63.9, and I divide that by 31.5. So don't round anything at this point. So you get 2.028571429. Don't round anything. And now we're gonna, in order to solve for B here, I have to turn this into a logarithmic equation. So take the natural log of this 2.028571429, and then the natural log of B to the 70, right? And then applying the property we talked about. So we're gonna apply the property of the exponential properties, remember? Well, that's actually the logarithmic properties. So applying that, you're going to bring down, so you still have ln of 2.028571429 equals 70 times the natural log of b, okay? And now, to get rid of the 70, we divide by 70. The 70's cancel, and we got natural log of b equals this. So we have to find this number. So the natural log, you have a natural log of 2.028571429, and I'm going to divide that by 70, and that's going to give us 0.01010474. Now we're going to have to use the exponential property. So we take Euler's number here on both sides of the equation to find b, and then we have e raised to this exponent, and remember that e and ln cancel, and so that gives us b. So b is e raised to this power, so let's see what that gives us. So there's Euler's number, 0.01010474, and that gives us 1.010155965. That's B. Okay? Now that you have B, we're going to round, and I think the rounding instructions, it tells us how many places for B. Let's take a look. For 19, it says to round, use integers or decimals, round to 4 places as needed. Okay, so we need 4 places. So 4 places is 1, 2, 3, 4. So it'll be up to there. So we're gonna, then B will be equal to, rounding to 4 places is 1.0102, right? 1.0102, rounding to 4 places. Now we have everything now to write the equation. So remember, we're using this form, the original form, this one. And we found B to be this number. So let's go ahead and write our function. Now we have everything we need to write our function. And so now the function is going to be, for A, is f of t equals the starting amount, which is 31.5. And then B is 1.0102 raised to the t. And then once we have the function, the next part of the problem is find, let's take a look at the, so now we have the function, and part B is what's the projected population in the year 2040 and 2050. So in 2040, I'm going to do one and you do the other. You just plug in the 40, right, into the function. Let's do that. Plug in 40 into the function. So f of 40 equals 31.5 1.0102 to the 40th power. And so that's going to give us, let's take a look, 31.5, 1.0102 raised to the 40th power. And we get 47 point, and then for this, 47 point, we round because we're looking at, let me take a look here at the problem again. Okay, because we're looking in millions, so yeah, 47.2 million. Rounding, right? So 47, actually 0.3, 47.3 million. Because it's money, we round to the nearest cent. So 47.3, actually 47.3 million. So in this case, it wouldn't be cents, right? Of course not, but it's a, you know, a figure of speech when dealing with money. So 47.3 million. That would be the answer for the year 2040. And you can do similarly for 2050, just plug it into the function here, right? So you plug in 50 instead of 40, and then you get the answer to the next question, okay? Now, the next part of this question is, let's take a look, and I think we have a question where, for C, it says, by experimenting with different values or by using a graphing calculator, estimate the first full year that this will exceed 60 million. We don't have to use a graphing calculator, or we don't have to speculate. We do the same thing we did as before. You know, in order to find the first full year where the population will exceed 60 million, you basically just, what we need to do here is you plug in 60 into the function and solve for t and round up 1 year. So basically what we have to do here is for the last part of the question is, let me take a look here. So you solve for C. This is what we do. So we write, so 60 equals 31.5, 1.0102 to the t, and solve for that and then round up the same way I did in the previous problem. So remember, we divide by 31.5. That's going to cancel that. And then so we get equals 1.0102 to the t. And over here we get 60 divided by 31.5. And we get 1.904761905, right? Turn it into a logarithmic problem. So take the ln of both sides. Equals ln of 1.0102 to the t. And now applying the logarithmic properties, t comes down. So we get t times ln of 1.0102 is equal to the ln of 1.904761905. And then you divide by the ln of 1.0102, divide by ln of 1.0102. And so t is equal to this ratio. Let's figure out what that is. So we get the ln of 1.904761905, and I divided by the ln of 1.0102, and we get 63.4938901. But we want the first full year where it will exceed 60 million, so we have to round up to the year 2064. So the answer here is 2064, right? So the year 2064 is when it will exceed, well, it will exceed 60 million, right? That was the question. The first full year in which the population will exceed 60 million is the year 2064, okay? Okay, so that is question number 19. And question 20 is our last question of this set. So we're gonna look at question 20, and it's It says that the average annual expenditures for a country consumer on a dairy product can be approximated by the function. Estimate the year expenditures for 2008 and 2012. And then assuming that the model remains accurate, what's the first full year in which the expenditures will exceed 440? So again, the same process. Now in this question, we don't have to find the function, so it's easier, right? So this one, just so that we don't make this video too long, since you have seen the process, we have the equation g of x equals 310.7 plus 40.2 ln x. X equals 6 is the year 2006. And then estimate the average expenditure in the year 2008 and 2012. And the expenditures, so for 2008, you just plug in x equals 8 into this function, right? So you do g of 8 equals 310.7 plus 40.2 ln, and then 2008, so 8. And this gives you, so I'm going to give you the number here, so to save us some time, 394.29 million, right? So that's what we get here for this part. Now, so and to do the next one, you just plug in 2012, you plug in the x equals to 12, okay? That's for that part. Now, let me go to the next part. So we are looking for the first full year that the expenditures will exceed 440 million. So remember the process. You just have to set up the equation as 440 equals 310.7 plus 40.2 natural log of x. And then solve for the x. So I can start by subtracting 310.7 from both sides, right? That's going to give me 123.03 on the left side. This cancels. And then 40.2 natural log of x. And then I'm going to divide by 40.2 both sides. And that's going to cancel 40.2. And so we get the natural log of x equals this number. And this gives you 3.21. So I'm just giving you the answers here so you can work this one because we've done enough of this. 1791. And remember, you make this into an exponential equation by taking Euler's number on both sides. That's going to get rid of the ln there because it cancels. And so you get x equals this figure, which is 24.93862758, which is the year 2024. But you want the first full year that it will exceed 440 million. So you round up to the year 2025, which is our year. So it works perfectly. Okay. Okay, so this is set number 2. This was a tough set. So spend a lot of time on these questions because they're not easy. Okay, they seem easy, but they're not. So I hope you enjoyed this set, and I will see you on the third set. Have a blessed day. Bye-bye.